Dear students, let us today discuss Kuvempu University BSc 3rd semester Geometrical Optics Session 4. Myself Dr. Niranjana AR, Assistant Professor of Physics. Let us today discuss aberrations. One of the basic problems of lenses is the imperfect quality of images. The simple equation derived connecting the object and image distances, focal lengths, etc., are based on the assumptions that the angles made by the rays of light with the axis are small and parallel paraxial approximation may be made. The refractive index and hence focal length of a lens is different for different wavelengths of light used. For a given lens, the refractive index for violet light is more than for the red light. Thus, if the light is not coming from the monochromatic source, the lens forms colored images. These images, even though formed by the paraxial rays, are at different positions and are of different sizes. So, the departure of real images from the ideal images in respect of the actual size, shape, and position are called aberrations. Aberrations are broadly classified into two categories. They are: first one, monochromatic aberrations. These defects are due to the wide angle incidence and peripheral incidences which occur even with monochromatic light are called monochromatic aberrations. Monochromatic aberrations are further classified into many types. Let us discuss them later in the coming sessions. Second category, chromatic aberrations. This occurs due to the dispersion of the light. It occurs with light that contains at least two wavelengths. Let us study, discuss in detail chromatic aberrations in this session. Aberrations that occur due to dispersion of light are called chromatic aberrations. Chromatic aberration occurs with light that contains at least two wavelengths. The refractive index of the material of a lens is different for different wavelengths of light. Hence, the focal length of a lens is different for different wavelengths. Since the magnification of the image depends on the focal length of a lens, the size of the image is different for different wavelengths or colors. The variation of the image distance from the lens with the refractive index measures axial or longitudinal chromatic aberration, and the variation in the size of the image measures lateral chromatic aberration. Figure illustrates chromatic aberration present in an image formed by a single lens L. AB is an object placed in front of the lens. A dash, B dash, and A dash A double dash, B double dash are the violet and the red images. The violet image is formed nearer the lens than the red image. The distance x measures the axial or longitudinal chromatic aberration, and the distance y measures the lateral chromatic aberration. The images of intermediate colors between violet and red lie between the images A dash, B dash and A double dash, B double dash, and their size increases from violet to red. At no one position the images are in sharp focus. Thus, a single lens produces a colored image of an object when illuminated by white light. This defect is called chromatic aberration. Elimination of chromatic aberration in a system of lenses is called achromatism. Go through the diagram carefully. Thus, a single lens produces a colored image of an object illuminated by white light, and this defect is called chromatic aberration. The elimination of this defect in a system of lenses is called achromatism. See the diagram. Object, blue image is in focus, green image is in focus, red image in focus. This is an illustration of axial chromatic aberration. Let us study some multiple choice questions. First one, the spherical aberration produced by convex lens is, the options are negative, positive, equal, 0. Answer is B, positive. Second one, the lens near the object is called ocular, eyepiece, objective, and field of view. The answer is C, objective. References for this session. First one, Optics by Ajoy K. Ghatak, 6th edition, TMH Publishers. Second one, Textbook of Optics, which is a revised edition for BSc classes as per UGC model syllabus. Authors N. Subramaniam, Brijlal and M.N. Avadanulu, Sultan Chand Publishers. Third reference is an internet link which is provided here. Fourth reference is also an internet link which is typed here. Thank you one and all.